Good morning, dear students. बच्चों, क्या आप मुझे सुन पा रहे हैं? Hello, dear students. Can you hear me? बच्चों, क्या आप मुझे सुन पा रहे हैं? Hello, dear students.
Yes, sir.
Okay. So, I welcome all of you to the chemistry class on date 17/11/2020. We may study today the example to understand the atomic mass units. We may even study about the atoms and molecules today. We may study about the various types of molecules, and we may study about the atomicity of the molecule. So now let's start studying the various topics. I hope you have on your screen the screen that I have shared. आप लोग को दूसरी स्क्रीन दिखने लगी है जिसमें मैंने अपने हाथों से लिखा हुआ है. बच्चों, क्या आपको स्क्रीन दिख रही है?
Yes, sir.
Yes, sir.
Okay, thank you. Yesterday we have revised a very important topic, my dear students. That was the topic about the that was the topic about understanding of the various understanding about how we can understand the atomic mass unit. So explain how relative atomic mass of an element is determined. Let us try to understand the relative atomic mass of an atom with one important example. So we have started studying this example and we have discussed it. Imagine a fruit seller. You need to imagine a fruit seller. This fruit seller does not have any standard weights. So that is why the fruit seller decides that he will use his own standard weights to make for all fruits. So to make the standard weights, the fruit seller selects one watermelon and says that the mass of this watermelon is 12 units. These 12 units, he called them as a fruit mass unit, FMU. Same way, the fruit seller makes 12 equal parts. Remember here, all the parts should be equal of this watermelon and considered each part as one fruit mass unit. So each part out of this that 12 parts, each part out of that 12 part is known as one fruit mass unit. And then he weighs the other fruits with the fruit mass unit, FMU. Then the fruit seller weighs the other fruit with the fruit mass unit, where we can find that some fruits like apple has 1 FMU, muskmelon has 6 FMU, and mango was weighing 3 FMU. So this fruit mass unit, the fruit seller himself has decided. Same way, my dear student, to measure the mass of the various atoms, we have, or the various scientists or IUPAC have decided the mass of, have decided atomic mass unit, which is known as AMU, which is also known as U as a unified mass. What they have done, they have taken carbon as a reference. And they said that the mass of carbon C12, the mass of carbon C12, let us say it is 12 AMU. So the mass of carbon C12, the scientists have called them 12 AMU. And then they took the weight of hydrogen, then they have taken the weight of oxygen, then they have taken the weight of nitrogen, and they came to know that hydrogen weighs 1 AMU, oxygen weighs 16 AMU, nitrogen weighs 14 AMU. This way, like the other fruit, like mango, muskmelon, see, by determining the uh, 12 FMU for one watermelon, the fruit seller has decided or have found that 1 FMU is your apple, the muskmelon is 6 FMU, and the mango was weighing 3 FMU. Same way, my dear students, the carbon C12 was weighing 12 AMU. The carbon C12 was weighing 12 AMU, but hydrogen was weighing 1 AMU, oxygen was weighing 16 AMU, nitrogen was weighing 14 AMU. And nowadays, this AMU is also not used, but we will call them as U, unified mass. So hydrogen is 1 U, oxygen is 16 U, and nitrogen is 14U, my dear students. So this is how the weights of various atoms have been decided, and we came to know that the weight of hydrogen atom is 1U, weight of oxygen atom is 16U, weight of nitrogen atom is 14U, weight of carbon atom is 12U. What is relative atomic mass? So what we have decided, just the 1 for hydrogen, 16 for oxygen, 14 for nitrogen, 12 for carbon is known as relative atomic mass. Mass of one atom of all atoms is related to 1/12 the mass of one atom of carbon 12. See here, it is related to this. As it is related to carbon, we call it relative atomic mass. I hope my dear students you understand. As it is related to carbon, we call it relative atomic mass. So the mass thus determined for all element is called the relative atomic mass, because for all element the mass whatever we have determined, that was related to the mass of the carbon 12 atom. Now we want to define the relative atomic mass. What is the definition for the relative atomic mass? The relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12 the mass of the one atom of carbon 12. Once again, relative atomic mass of the atom is defined of an element is defined as the average mass of an atom as compared to the 1/12 the mass of the atom of one atom of carbon C12. So this is the definition that we can give for the relative atomic mass. Now my dear students, we want to know how do this atom exist? How do atom exist? Atoms of most of the element are not able to exist independently. So the first thing you need to remember that atoms do not exist independently. These atoms, they do not exist independently. So first thing that we can come to know is that these atoms do not exist independently. Atoms forms molecules. So atoms forms molecules and ions, and these molecules or ions aggregate in a large number to form matter. So atom exists by combining. When they combine, they form molecules or ions, and then these molecules or ions, they aggregate to give us the matter. This is how the atom exists. But remember that atoms do not exist independently. Remember that atoms do not exist independently. Atoms cannot exist independently. This is what we need to remember. An atom combines, when they combine, they form molecule or ions. These ions and molecules again aggregate and they form matter, and that is why each and every matter is made up of atom. What is molecule? Now, the next thing that we need to understand is molecule. A molecule can be defined as, now we have to study the definition of the molecule. The smallest particle of an element or a compound. Remember, molecule can be of element, molecule can be of compound. The smallest particle of an element or a compound that is capable of an independent existence and show all the properties of that substance is called molecule. My dear students, remember that when we want to study about molecule, we need to remember three things. First thing is that molecule is the smallest particle of an element or compound. Second thing is the molecule is capable of an independent existence. And third thing is the molecule shows all the properties of that particular substance. That means that particular element or that particular compound. And molecule can be of element, molecule can be of compound. So we can say that there are that molecule be we can have the molecule of element, we can have the molecule of compound. Once again, let us revise so that you can understand it well, my dear students, and you do not have there will not be any doubt to you. Let us understand it well. What is molecule? A molecule is a molecule is let us see it. A molecule can be defined as, or molecule is the smallest particle that exists independently. A molecule is the smallest particle of an element or a compound that is capable of an independent existence and show all properties of that substance. So I hope, my dear students, by remembering those 3 points and by remembering that the molecule can be of element, the molecule can be of compound, you can easily remember the definition. Now, my dear students, in general, how do we understand molecules? So in general, molecule is a group of two or more atoms that are chemically bonded together. So we can even understand molecule in the another or with the other words that molecule is a group of two or more atoms that are chemically bonded. But here in this definition, we do not talk about the four important points. So when exact definition is required, you should write the definition with 4 points or 3 points and molecule of element and molecule of compound. Next, how molecule is formed. So my dear student, molecule is formed atoms of the same element, please remember, or atoms of the different elements. When they combine, when they join together, they form molecule. So molecule is formed by atoms, molecule is formed by atoms, molecule is formed by combination of atoms and molecules of same element or atoms of same element or atoms of different elements. When they combine, they form molecule. So this is what you need to remember, that molecules are formed by joining the various types of or same types of atoms when they combine together. What are the two types of molecules? So we can have two types of molecule. One, molecule of element, molecule of compound. Molecule of element, let us define the molecule of element. Molecule of element are constituted by the same type of atoms. So those molecules which are made up of the same type of atoms, They are known as the molecules of elements. But when the molecule is formed by the different types of atoms, when the molecule is made up of the different type of atom, my dear students, we get molecule of compound. So what is the molecule of compound? Molecule of compound is the atom of different elements joined together in definite proportion. Now you need to remember this, that when we get the molecule of compound, they should be joining in a definite proportion to form molecule of compound. Once again, atoms of different element join together in definite proportion to form molecule of compound. Now, my dear students, we want to study the next topic, which is known as the what is atomicity, and we need to write the atomicity. We need to write the atomicity for the various elements like argon, helium, oxygen, hydrogen, nitrogen, chlorine, phosphorus, sulfur, ozone, and neon. So, my dear students, first let us understand about the definition of atomicity. Let us first understand the definition of atomicity, my dear students. Atomicity, my dear student, is the atomicity is the number of atomicity is the number of atoms constituting or present in a molecule is known as atomicity. Is known as the atomicity of the molecule. Once again, the number of atoms present in the molecule is known as atomicity. Or in the other words, you can say that the number of atoms constituting a molecule is known as the atomicity of the molecule. So this is how, my dear students, we really understand about the atomicity of the molecules. The atomicity of the molecule is the number of atoms. The atomicity of the molecule is the number of atoms that are present into the molecule. This is how we understand about the atomicity of molecule. Now you can see on your screen that we have the various atoms, we have the various elements, and their atoms are written, and we even have the atomicity written for them. So let us study them one by one. We have a table. In table, first we have the name of the element, then we have the symbol for its molecule. What kind of molecule does the element make? And then, my dear students, we are going to study about the atomicity. Here, when you look at the first element that we have is argon. You can see, my dear student, that the argon makes the molecule of like Ar. That means only one atom. That means only one atom is present in the molecule. And one means mono. If we consider one as mono, then it is monoatomic. You can see even in the case of helium, it is also having the one atom. And that is why helium is also monoatomic. But the molecule of oxygen is O2, so it has got two atoms. And that is why oxygen is diatomic. See, when the molecule is made up of one atom, it is monoatomic. When molecule is made up of two atoms, it is diatomic. Same way you can see for hydrogen, the molecule is H2, and that is why hydrogen is diatomic. For nitrogen, the molecule is N2, and that is why nitrogen is also diatomic. For chlorine, the molecule is Cl2, and that is why chlorine is also diatomic. So you can see that oxygen, hydrogen, nitrogen, and chlorine, they have, my dear students, they have two atoms present in their molecule, and that is why they all, oxygen, hydrogen, nitrogen, and chlorine, they are diatomic molecules. Now, my dear students, we want to know about the phosphorus. So when we look at the phosphorus, you can see that the molecule of phosphorus is written as a P4. That means in one molecule of phosphorus, it has got 4 atoms. And as the one molecule of phosphorus has got 4 atoms, it is known as tetraatomic. Same way, when you look at the molecule of sulfur, my dear students, the molecule of sulfur has got 8 atoms, and which is known as the polyatomic. You can even call this S8 as octaatomic. Octa means 8. 8 atoms present, that is why we call it octaatomic. So this is how, my dear students, we come to know about. But when the number of atom is more than 4, we start calling them as a polyatomic. You can see when we think of ozone, ozone has got 3 atoms in its molecule, and 3 is represented by the word tri, and that is why we call ozone as a triatomic molecule. You can again see in the case of neon, neon has got only 1 atom, and that is why again neon is monoatomic, my dear students. So this is how, my dear students, we understand about the various molecules. If we really want to study about them again, let us revise them. As you can see, helium, then neon, then argon, then krypton, then xenon, radon. These all are monoatomic. If you want to look into the diatomic, my dear students, diatomic, we find this oxygen, nitrogen, hydrogen, then chlorine. These are diatomic molecules. They have 2 atoms. If you look for triatomic, then you have the example of ozone. Ozone is triatomic. If you are looking for tetraatomic, you can think of phosphorus, which has 4. Or if you are looking at polyatomic, that is your S8 sulfur with the 8 atoms. So this is what it was, the revision of the previous table for you, my dear students. I hope you understood about the atomicity of the molecules. If you do not understand the atomicity of molecule, you can ask me the question. बच्चों, अगर कुछ समझ में नहीं आए तो आप मुझे पूछ सकते हैं, कोई डाउट है तो पूछ सकते हैं. कुछ पूछना चाहेंगे बच्चों, कुछ पूछना चाहेंगे? चलिए, then
No, sir.
let's move. Thank you. Let's move and understand the next. Define. Now we need to define the various types of molecules. So we are going to define diatomic molecule, monoatomic molecule, tetraatomic molecule, and polyatomic molecule, and triatomic molecule. Let us first start with the diatomic molecule, my dear students. Let us first study about the diatomic molecule. So now we are going to study about the diatomic molecule in detail. What is diatomic molecule? Can you read on your screen? बच्चों, आपको दिख रहा है कि आपको बोलूं तो आप पढ़ पाओगे diatomic molecule के बारे में? This
Yes,
is what
sir.
is the definition of diatomic molecule. A molecule that is constituted by 2 atoms is called diatomic molecule. A molecule that is constituted by two atoms is called diatomic molecules. Nitrogen, oxygen, hydrogen, chlorine molecules. Molecules of nitrogen, molecule of oxygen, molecule of hydrogen and molecule of chlorine are diatomic molecules. So now, my dear students, we will study about the monoatomic molecules. Let us study about the monoatomic molecules. Let's have a look to the monoatomic molecules. Monoatomic molecule that is constituted by one atom, remember, is called monoatomic molecule. Helium, neon, argon, krypton, xenon and radon. Akash K. Buria, please do not disturb the class and remove it. Aje તમે કર્યું છે એને remove કરી લો, please. Please remove whatever you have done. The monoatomic molecules are helium, neon, argon, krypton, xenon and radons. Molecules of inert gases like helium, neon, argon, krypton, xenon and radon are monoatomic molecules, my dear students. Then we want to study about the tetraatomic molecules. So here we have the definition for the tetraatomic molecule. Dear students, you can see here. Let us read it. Tetraatomic molecule. The molecule that is constituted by four atoms. Remember, the molecule that is constituted by four atoms is called the tetraatomic molecule. The example of tetraatomic molecule is P4. Then we have the next one, polyatomic molecule. Let us understand the definition of the polyatomic molecule, my dear students. That polyatomic molecule that is constituted by more than four atoms is called polyatomic molecule. For example, we have sulfur, which is made up of 8 atoms, and that is why S8 is called polyatomic molecule. Now we want to study the definition of triatomic molecule, my dear students. So you can see the definition of triatomic molecule. Molecule that is constituted by 3 atoms is called triatomic molecule. Example is ozone. So this is how, my dear students, we understand about the atomicity and the atoms and molecules. Now let us move and study the next topic. The next topic is about the structure of metals. So what kind of structure is shown by metals and some other elements? So metals and some other elements such as carbon do not have simple structure, but they consist of very large and indefinite number of atoms bonded together. Please remember that metals and some other elements, they do not make the small molecules. They do not have the simple structure. So elements such as carbon and metals, they do not make molecules with the small number of atoms, but they make a very large, remember, they make a very large and indefinite number of atoms. They take very large number of atoms, their molecules are very large, and they have indefinite number of atoms bonded together in their molecules or in their structures. So metals and some other elements like carbon, they make the structure in such a way that they have large number of atoms present into them. The number of atom is indefinite, means we cannot determine, or which is not fixed, and this is how, my dear students, we understand the structures of metals and some other elements. Now, my dear students, we want to study the next point, that is about the molecules. Explain molecules of compound like water, ammonia and carbon dioxide with their formula, their combining elements and their ratio by mass. Dear students, we have studied that the element combined together in a fixed ratio. Please remember, element combine together in a fixed ratio to form compound or to form molecule. This water, this ammonia, and this carbon dioxide, they are actually compounds. These compounds are made up of elements. So elements, when they combine together in a fixed ratio, they make molecules, and these molecules aggregate together to make compound or matter, that is what it is known as the compound. So here we have three compounds: water, ammonia, and carbon dioxide. Here, my dear students, we have three compounds. These three compounds are water, ammonia, and carbon dioxide. If we write their formula, the formula for water is H2O, the formula for ammonia is NH3, and the formula of carbon dioxide is CO2, that you have already studied in your previous standards. Now you can see that these compounds are made up of some elements. So you can see that water is made up of this element and this element. Ammonia is made up of these element and these element. Carbon dioxide is made up of this element and this element. These elements have their symbols that we have seen, that hydrogen, H is the symbol for hydrogen, O is the symbol for oxygen, and that is why we can say that water has two elements, hydrogen and oxygen. Same way, N is the symbol for nitrogen, H the symbol for hydrogen, and that is why we can say that ammonia has two elements, nitrogen and hydrogen present. When it comes to the carbon dioxide, it is made up of two elements, carbon and oxygen. And we can say that carbon dioxide is made up of carbon and oxygen. Now, my dear students, we should know their masses. So here in the table, I have written their atomic masses for you. You can see them easily. The atomic mass for hydrogen is 1. The atomic mass for oxygen is 16. For nitrogen, it is 14. For hydrogen, it is 1. For carbon, it is 12. For oxygen, it is 16. You can write U after that, which is the unified mass. Later on, we will write gram per mole, but first we need to understand with the U. So now you can see that each element has got some number of atoms present with them. So when we look at the formula, my dear students, we come to know that in water, we have two atoms of hydrogen and one atom of oxygen. But this one we do not write. So hydrogen has got two atoms and oxygen has got one atom. But the mass is 1 is to 16. So, for two atoms, the total mass would be 2. See, for one atom, the mass is 1, but here we have two atoms, so total mass is 2. Total mass of one atom of oxygen is 16. Now, if we simplify it, if we write it in this way, 2 divided by 2 into 8, this 2 into 8 I have written for 16. So this 2 and 2 get cancelled. We write 2 into 1 and we get 1 by 8. So the simple ratio is 1 is to